Hello, my name is Jinling Li, and I am an Inside Data Engineer Fellow. My project is KOL Trend. Suppose I am a consultant, and one day my client came to me complaining about the sea of information from social media, let's say Reddit. The client described that Reddit website shows trending today, popular posts, communities. That is not what he wants. The client want to discover what those eye catchers or opinion influencers are talking about. However, Reddit does not provide that function. So after a case study, my solution will be find the key opinion leaders, KOL, and follow up their post in social media. I am proposing to build a recommendation system from which users can identify who the KOLs are and then search their top post from Reddit. This system will be helpful for data scientists to predict opinions trending, also for business owners to determine business strategies, especially useful in advertising, marketing, news media, and consulting area. The input data is JSON file. Each contains 60 fields, and the average size is around 60 gigabytes. Total processing data size is larger than 500 gigabytes. The formula designed is calculate interest with aggregation of score, number of comments, number of cross posts from the specific post. The end data will be a table with these columns and stored in a relational database. So for a certain author, he'll get an interest score for each post he published. Let's explore it in a live demo. First, select a subreddit and a period, submit. The top 10 authors with interest are listed here. On the left is the author ID, on the right is the interest score. So you may want to be interested in this author ID, enter here. Then the top post from this author is listed here. These are all linkage, can directly redirect you to the website. This time, refresh it to subreddit. So this time you want to try a different time. You already remember the author ID here. Then in this way, the post from this author is listed here, but under a different category. So here is the tech stack. Reddit data is downloaded and stored in S3. Spark read data from S3, process and transforms, and then uploads to PostgreSQL. Then the system is visualized through Dash web application. Airflow is applied to manage and automate the workflow. Spark is a distributed computing framework that utilizes MapReduce for parallel processing. A driver creates a job and schedules the tasks. Cluster manager then assigns tasks to executors on the work nodes. Spark reads JSON data into data frame. Spark SQL does the queries, data shuffling, and uploads into the database. So this procedure is the bottleneck and projects many issues, such as latency and storage cost. To overcome the bottleneck, Spark performance tuning techniques are applied. For data serialization, I chose data frame over RDD because data frame can serialize the data in binary format and perform transformation directly on memory, where RDD uses the Java serialization to encode the data, which generate expensive overheads. Specify schema prior to reading JSON file helps Spark understand the schema. Repartition of data frame is also considered. Finally, converting JSON file to Parquet is demonstrated to be an efficient way. Parquet is a columnar storage compressed format that contains metadata about content. Reading and parsing Parquet files are faster than JSON files. From a memory tuning and management part, the main parameters that affect cluster performance are the executor memory and the driver memory. So this configuration can be done in adjusting Spark submit flags. From a hardware provision, Spark benefits from having more memory and cores. So I increased to 9 EC2 instances. Using a larger number of local disks can help accelerate the performance. I increased EBS volume to 100 gigabytes. With all those performance tuning techniques, before tuning, Spark can handle a 10 gigabyte JSON file at a time. Larger file will bring in out-of-memory errors. After tuning, Spark can process up to 100 gigabyte JSON file without problem. Before tuning, processing 100 gigabyte can take 60 minutes. After tuning, it reduced to 10 minutes. Converting JSON to Parquet reduced the storage cost in database. Finally, response time from API also reduced. So these results demonstrate the success of optimization, also testify the API's feasibilities and stabilities. My name is Jinling Li, and I am a STEM PhD from Virginia Tech. I have another master's degree in computer science. Previously, I was a research analyst from investment banks or hedge fund. Then I joined a tech company to do some data engineering work. Now I am living in Seattle with my family. There is a fun fact about me. So at our first set, 90% think my name is Jinling, which is a fairy in Mandarin. Actually, it's Jinling. But I think it's very interesting and I feel like it a lot. That's it. Thank you very much.